We have found 4 sources of information, which is the first one is from Journal of Physics conference series with the topic The Monitoring of Harmful Algal Blooms in Sabah, Malaysia. The second one is from Conserve Energy Future website with the topic Causes, Effect and Solutions to Algal Bloom on Aquatic Ecosystem. The third one is from ResearchGate with the topic of Control and Management of Harmful Algal Blooms. And the last one is from NCBI website with the topic is Approaches to Monitoring, Control and Management of Harmful Algal Blooms, HABS. There are 4 impacts of algal blooms, which is the first one is production of harmful toxins, causes the death of aquatic life, detrimental effect on human health, and the last one is economic loss. The first point is production of harmful toxins. Some microalgae species that form algal blooms produces toxins, like for example, Pyrodinium bahamense, which is a dinoflagellate which produces saxitoxin. The second one is causes the death of aquatic life. Algal bloom causes harmful effect on fish, shellfish, marine mammals and birds. It also causes fish kill by clogging their gills and the fish die from lack of oxygen. For example, in Kota Kinabalu and Tuaran, have experienced fish kill in 2005. Algal blooms also increases the competition for oxygen, which lead to suffocation of aquatic animals. The third one is detrimental effect on human health. Paralytic shellfish poisoning (PSP) from algal bloom causes 7 deaths and 202 victims suffering in Sabah in 1976. Toxins from algal blooms, which bioaccumulate in shellfish, has caused harm to people who consume them. It also causes strong irritation, itching and skin diseases when such contaminated water comes into contact with the human skin. The last point is economic loss. The death of aquatic life affect fishermen who depend on fishing as an income-generating activity. For example, Sabah Fisheries Station, which was situated in Tanjung Badak, Tuaran, suffered a huge loss due to the mass fish mortality. Also has been reporting losses where losses were amounting to 150,000 according to fish cage operators.
These harmful algal blooms issue need to be solved. 2 approaches are proper sewage treatment and the red tide monitoring system. Red tide monitoring system has been conducted since 1976 to safeguard the seafood safety. The monitoring area covers all the Sabah coast and been conducted at 69 different stations. This is along with the Ministry of Health Sabah. This method is to mitigate and manage red tide occurrence in Sabah. Here is the flow of red alert system. First, the Director of Sabah Biosecurity Fisheries Division will issue out a letter as an early precautionary measure. Then the office will inform the district officer, village heads, chairman of village community and district health office to refrain locals from eating shellfish at affected area. Lastly, the Director of Department of Fisheries Sabah will issue a press statement to advise public and also banning any selling or collection of shellfish. Other solution is proper sewage treatment. This treatment is to limit the presence of nitrate and phosphorus. There will need a 5-step treatment to achieve the optimal treatment. The removal of nitrate and phosphorus is using the nitrification process. This method will help avoid excessive nutrients from entering into the marine ecosystem.
Next, I will tell you about the duration of implementation to reach solution goal. The first record of harmful algae bloom in Sabah was in 1976, where 202 victims were reported to be suffering from paralytic shellfish poisoning and 7 deaths. Since then, the Department of Fisheries Sabah has been doing monitoring to safeguard seafood safety, especially shellfish harvest for food consumption. Sabah is the only state in Malaysia in which the monitoring program is done consistently throughout the year since 1976. The implementation of toxin monitoring between 1984 to 2013 was considered successful. Due to this effort, the paralytic shellfish poisoning cases involving the public has declined during the last 40 years without duly affecting the income of fishermen and fisheries industry. But the bloom recurred back in 2013 where 3 deaths were reported.
The management of algal bloom must consider the entire cycle of the water column through the catchment, water reservoirs, treatment plants, and distribution system. Appropriate management of algal bloom is imperative to reducing their negative impacts on humans and ecological health, water treatment process, and income-generating activities including tourism and property development. This is not simply about implementing prevention and mitigation strategies. It is also important to assess the potential risks associated with blooms so they can be treated effectively and efficiently at the site of interest. This management will reduce or eliminate the undesirable consequence of the algal blooms on both humans and ecosystem. The management plan should consist of the following action required during 4 distinct time periods. First, prior to blooms. Second, hazardous bloom suspected. Third, hazardous bloom identified. And fourth, mitigation ineffective. Next, this is the example of management framework for the removal of toxic cyanobacteria in the water column. These management plans consist of the following action that need to be done during the different 4 distinct time periods of the blooms, which are prior to bloom, hazardous bloom suspected, hazardous bloom identified, and mitigation ineffective.
There are 5 strategies of control that can be used to reduce the harmful species of algal bloom, which are mechanical, biological, chemical, genetic, and environment. First of all, mechanical control is a control that used by elimination of harmful algal bloom cells from water by dispersing clay over the water surface. Particles of clay clump each other with harmful algal bloom cells and remove the cells through sedimentation. Next, biological control are using pheromones to control insect pests. Is still reasonable opposition to release concept organisms to control others in ocean. Thirdly, chemical control is one of control that used by relies on release of toxic chemical. This includes potential developments of species-specific chemical control agents. Fourthly, genetic control are using alteration of environment tolerance, reproduction, and processes of unwanted species. This control strategy is seen in many ways with biological control with concern about negative impact to organisms that not origin from that area. Lastly, environment control are using of manipulation of environment, which is modification physically or chemically of the environment. This modification may involve large-scale manipulation levels nutrient.